Let me remove my phone. Now, see, hello. You see this bracket? Eh? What is happening? You will have exhausted all the ink. I needed a different color. I had a green. I hope you are not using the green. Okay. Now, you see this one? Is this one? Are you following me? Eh? Okay. This very one, blue, is for this. Is it not? Yes. Okay. Now, I will come back to my green. You see this one here? This one, eh? And this one are together. Is it not? Yes. We only have one left, eh? Which is this one. I will use it as blue. And this one, which is for this, is it not? And this is for this. And this is for this. Okay, fine. What do we do first? The first you will find, you will do is the innermost, which is, so you will take out V1, call of B0. Your V has been defined as Vx, Vy, Vz. Cross off, you have 0, 0, B0. Now you see, when you have this, you know it is equal to the magnitude B0 multiplied by what? The B0 naught, eh? Okay? Which is the wave, the unit weight, eh? Okay. Now you will see that this is actually Z. So, what do? That is exactly equal to EX, EY, EZ of Vx, Vy, Vz, 0, 0, B0. Is that okay? And then you're going to get EX into, you will remove this. So we're going to have B0 Vy is what we're going to have here. B0 E of Y. I have minus E of Y. What I will do, remove this and remove this. So I'm going to have minus B0 E, that is V of X. Am I correct? Then plus E of Z, that will be 0. That's exactly what you will get. Now, we have done this. The next that will follow will be call of this. So you're going to have call of V1, call B0 will give you call of the result we have, which is the call of B. This is V, sorry, of Vy, not E. V of Y minus b0 v of x and 0. That is what we're going to do. Did you get that? Okay. If you have done that, you will have vectors of this form. You remove this. You remove this. So you're going to have plus partial by partial z. Partial by partial z of b0 v of x. Is that correct? The next one will give you this will go, this will go, this is 0, that becomes plus of EY, partial by partial Z, B0, V of Y. Is that okay? Now, the next one will be a combination of X and Y. So you're going to have plus E of Z into, I will remove this and this. So I'm going to have minus partial by partial X of B0 V of X minus partial by partial Y B0 V of Y. So this is what you will have here. Is that okay? So you see, now we have obtained that. Which one are we going to do next? This is the next. So we are going to use this and cross off B naught. So you are now going to have this call into V1, call of B0, call of B0. So that is exactly what we want to do now. Having obtained this one, which is V1, okay, V1 this. There's a call there, eh? So we have call of that, which we have. Then we're going to call this again, eh? So we will now have that as So that is what we are going to get. Eh? So if you do that and then simplify, you will get something that looks like this. I will write to see whether you have that. Did you get this? So anyone I'm writing, you go and confirm. Huh? Okay. Now the last one is for us to do the bigger bracket now. What is left there now is for us to take B0. So we're going to use this. Call of V1 call B0. I will cross it. I will cross it. That is, I have this call of whatever call B0. So we will take this. We will take that and find X call. So we are taking this and find the call of B. So if I'll just write the answer, I have call I have call, so this is not there. I have call of this. So check that you will have this answer. B naught squared into, that is B naught squared into E of x of partial 2Vx by partial x squared plus partial 2Vy by partial x partial y plus partial 2Vy. Is it Vx? Vx all over partial Vx over partial 2z squared plus Ey into partial 2Vx by partial x partial y plus partial 2Vy by partial y squared plus partial 2Vy by partial z squared plus Ez of 0. So this is the answer you're supposed to get once you get that. So that is where you will now see will be our problem. Did you get that? Because that is where you will get. And then when you get that, we'll now begin our small assumptions to modify the problem. You'll now begin to, you can go before this one. Still go up. Go up again, let me see. Oh, that's the last one. Okay, don't worry. No, just go back. Go back. 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 Okay, just stop here. Come down a bit. Okay, come down. Aha. Perturbation relay. Okay. This is exactly where we started. You see, equation 5.26 is what is leading to this. Because now I now discover if I take in homogeneous magnetic field, it's going to cause trouble for us. So we decide to take it uniform. All right? So that's why the second term that has call and or B, I omitted it in that last equation I asked you to do. So we concentrated on this. So if this one could take all of you a whole night without yawoing, so you can imagine. Okay, so we'll take that. We'll now see that after that 526, you will put this result in place of the last term. Are you seeing that? Huh? See, they said my note was empty. That empty is for you to justify your presence. That the food they are giving you is not for nothing. And the new faces you are seeing also is nothing. But now, you didn't do that. Now, there's some assumptions we want to make. If you look at that, since the x and y directions are not affected by gravity, gravity is only in the z direction. What happens? We can simplify the problem by adopting a two-dimensional system. We will do what? You see, that is where the difference between you that have been in school and the farmer. And they told us to be doing it like this. And we have been doing it. Why do we do it? They told us to do it. You see, that mentality should be off. You should know what the reasons to give for what happens. Third law says action and reaction. So if you do not make this, you will not get this. Okay. Now, if you do that with this thing we have gotten, I will write the next step you are going to get. I did not include it here because I wanted us to do something. See, I'm solving the whole thing now. Organizer, are you going to pay them money? So they will give me 10%. So whenever you give me their contacts, and then I will instruct their bank once money comes. Oh, that's in future. Yes, sir. In future, tomorrow is future. Yes. Now, listen. How did we define G? This is X, this is Y, this is what Z. So, you see, they are not affected. Now, our problem will be in the XZ plane. It will be where? In the XZ plane. But let's go on. You will see what will happen. We are talking about G now. Because where the gravity has effect is in Z. That makes you to take a two-dimensional approach because Z is not affecting, X is not affecting, or Z. G has no influence on the X and Y directions because they are zero. So the next thing you should be able to get, which I did not write, can I clean now? I hope you have taken to know where you will start. If I were you, you should have a red or green pen. As I'm getting here, you will now use a different color of pen to write this, signifying I must work to get it. Okay? Yes, ma. Huh? Yes. Don't worry, we'll see. I think I gave you a diagram. Go back to chapter 4, lecture 4. Go to chapter 4. Go back. Go. There's a place I did something. I mean, they didn't capture it. Go back, let me see whether it's there. But I know I put that diagram. You know, can you mute this? Organizer, is it muted? You know, when we stay in our small classroom with board solving, when we get the result like this, we say, "Oh, nyega begu iya." So we'll start dancing. Whenever you get, is the mathematician say, "Eureka, eureka." But we want to feel the flavor of life and physics. Because without physics, life meaningless. Without fluid, life is meaningless. You can't live. Everything about is fluid. Your toothpaste is fluid. The air is fluid. Everything is fluid. Without fluid, there won't be lubrication. You see that? And without fluid, there won't be transfer of energy. Oh, nyega, yeah. You see? No.
Nicholas said, "We want to place for this nice part."
No. So you understand life, because there must be life. You don't just sit down, fry your face like what we used to do. My lecturers used to do mathematics. They will not comb their hair. They will wear slippers and get to the office. They might decide after working, they remove one leg of the slippers and walk bare so that people will see mathematics is hard. It is not hard. Where is that lecture? NMC. Where did I put your lectures on? You see? No, there's one. This. Not this one. Where did I dump your lectures? This is mathematical. Okay, let me see what I see. Oh, this is mathematical notes. It's not here. You're checking whether you will see it. I think you've seen it before. No. No, look at it. So. See, this will make me to sweat, oh. Thank God I slept last night.
Oh, I'm happy about that.
You are happy?
But I ate very early today.
Very early.
Yes,
How did you feel?
I say I'm feeling better.
Try it, and you get used to it.
Yes, but I've not started eating early, late from evening.
No, don't worry. Try. it will take you time to adjust.
But I didn't sleep well.
Because he was taking the belly. You see, the point is that the stomach and other parts of your body communicates the information under the network to the brain. Now, if the tummy is craving, it will tell you, I need this, I'm hungry. Your willpower now determines, am I hungry? The response you give will make the tummy to continue or not. You can say, okay, since the thing is coming too much, let me take 1 glass of water. Don't go for anything that has anything, just take water and see, it will quieten. But some people, when it does like that, they'll go and eat. You are creating problems. See the
It's not in the
they omitted it. Can you hello? See, can you snipe that? Can you snipe it and then dump it somewhere, then save it? I have a sniping code there. See what to do. New. Go to new. It has taken it. Where do you want to paste it? Close it. Minimize. Oh, okay. Put the here and copy it. See. You put it here. Okay, you've taken it. Then where are you going to put it? You said a new one, so that it'll be easy for you to. Where is it? Okay. Control V. Okay. So you can now save this, dump it anywhere you want to dump it. Okay. I use it a lot because there are figures you will try to reproduce. It makes it easy for you. I can give you a link. Have you saved it so that you can go to my email box and then, okay. PDF. Okay. You saved it. Okay. It should be on my this thing now. So, Mrs. Indo, see. X, bold it, make it a little bit bold. You see, we are tentatively taking Z and X. So we are working in XZ plane. You can turn it to put the direction, but it doesn't matter. Okay. Okay, so the next thing, okay, sir. You can put this thing on now. You can shift my system, let it be charging. Alabe. Huh? No, I want him to put it on. Okay, fine, okay. So, my dear friends, you can see where we are. So the next thing you should get after we have made that assumption, you should be able to get the density of V1 by T squared minus of V1 dot grad of P0 plus CS squared of rho of the divergence of V1 I will close minus of 1 over mu 0 of B naught squared into partial 2Vx by partial x squared plus partial 2Vx by partial z squared of 0 plus d of this rho 0 V1. I take this and put my G. That should give us 0. Because if we have taken that, you will now notice that all things you had in the direction of your x should vanish. That is why I am putting it 0 there. Of course, we ended up having that the z direction is 0, so we don't need that. So this is x and this is what? Y. Now the next thing for us, we can simplify that further by taking, you can simplify further by taking that the grad will be equal to partial by partial z, because that is the direction of our action. So, in place of this, and then you know what we define our Vx and Vy. So, if we have done that, of course, you have that this will be partial by this will be 0, and you have this. We'll be able to get that because there is no differentiation along the y-axis. All that will be 0. Are you following me? Okay. Now, you will see that grad of P naught, for example, because P naught is a function of z, the partial P naught by partial x will vanish, but partial P naught by partial z will survive. Are you following me? Huh? So if you do that, you should be able to get something that looks like this. Just confirm. Partial 2. I will put my rho 0 of V1 by partial t squared minus of this grad is still there. I will have Vz by partial P naught by partial z plus CS squared rho naught. I will have partial Vx by partial x plus partial Vz by partial z. That will remain, and I will close this. Now the next thing you will have is from here. We will take this now. That should be able to give me minus b naught squared over mu naught. What I am going to have inside should simply be partial squared vx by partial x squared plus, let us not forget, partial 2vx by partial z squared. I will have 0 because I'm taking this as 2 dimension. So if I want to still take the 3rd dimension, because they are all 0, 0, so that we can now take the last one. We'll give you this one. You should be able to have rho 0 partial vx by partial x plus partial by partial z into rho naught of vz, all of this in your G. So that's the next thing you should be able to get. Now, having obtained that, we can now write the problem in component form. You see the one that is x-axis, the one that is y-axis, and the one that is z-axis. But of course, you will see how the problem will come. You will see the S component of the problem will simplify, and you will have the Z component. Because the problem is in 2 dimensions, we must have the S component and the Z component. Okay? Are you following me? For example, you will see that the S component does not have G. In fact, let me write the G the way it's supposed to be, so that in place of that G, you are having 0, 0, I think minus G. So you will see that the S component does not have G. It's only the Z component. So can you get the next step? Write the X and the Z components. I think I gave it to you in your notes. Okay? Can you move up small? Let's see whether that one is there. Up. Keep going. Keep going up. Go up. That's the end. Oh yeah, come down. Because that's the place I did it. Come down. Wait, wait. Up 1 minute. Just down. Aha. Now you see. We will get to 527 and 528. Eh? Okay? From that result now, put them in component form. And you know how we define our VA. VA is the Alfvén speed, is it not? So when you do that, you get to where you are going to use the Alfvén speed. Already the acoustic speed CS is there. Are you following me? Huh? So the next step you would do is to get 527. Next step. Is to get equations 527 and then 528. So that's a task you would do. The thing has been is for you to separate them into this component form that you now have. You discover the pressure will go. You won't have pressure there again. You will ask me how. I want you to do that. So, if you obtain that, you can move further by including this problem by defining your VA. What is our VA? What is VA? What is it? Is it B naught squared over what? How did we define half-inch speed? By now you should know it. Huh? I got them now. If I tell you I will eat your lunch in my small tummy, who wants to give me his lunch today should be able to. You see, there are parameters you should know. If I tell you I will eat your food, I will eat it all. Huh? What is half-inch speed? Where is half-inch speed? Oh, half-inch speed squared. Oh, did you see something like this? Huh? Did you get something like this? Half-inch speed is defined in relation with the permeability and then rho density. It is the CS squared. CS squared. What is CS squared? That is acoustic speed. What is it? Is it not gamma P naught over what? Over rho naught, is it not? So we should be able to get this. And then it should be with us. So, from this and the use of this, you will see how the problem will be transferred. You will get that, the transformation of the problem. So you do that this night. Now, the Z gives us that. Is it not? How do you people say Kachiko? Or Hakani? Or Kagani? So which one now? Is that understand? Uh-huh. You know, I left Hausa land since 20-something years, but I still pretty small. But the one I don't forget is Akuya. Every time I will remember Akuya. Then another one is Dodon Doya. Dodon Doya. What is Dodon Doya? Bad masquerade. Or what? What is it? Eh? Dodon Doya. What is that now? Bad masquerade. Uh-huh. Okay. So now we can now take a Fourier, because the way the problem is here, it might not be easily solved. So we'll take this. By now you should be able to do that Fourier transformation. Anywhere you see Vx, you put that. Anywhere you see this, you put that. The whole problem now will now generate a problem in terms of what? Frequency and wave number. Next slide. So it will give you that problem in terms of wave number and frequency. So when you get to that, it is good for us to do what we call non-dimensionalization. The idea of non-dimensionalization is to remove all dimensions. Like the velocity, we know is meters per second, is it not? But when you non-dimensionalize it, it becomes ordinary value. That helps us so that you don't begin to look for the units. Huh? Organizer. Uh-huh. So, when we look at non-dimensionalization, for example, we say Z should represent HZH, which means we are writing this in length scale. We are doing it in what? Length scale. And then how do you do that? For example, I hope my hand will reach. This one is better than the other one. The weather is becoming drier. Now, for example, we said Z is equal to H of Z of what? Of ZH. Now, where the Z's are appearing is D2 dz squared. We need to remove that. So, you have D by dz. We want to write it in length scale. So, that will give you D2 of this, give me of this, in place of this Z. If I take this, I will see that I will have H of this all squared. That gives me D2 by dZh squared multiplied by 1 over h squared. So that is how we'll do it. Because there are other ones that you see h coming. At the end of the day, the h squared will cancel out. And then you will come to your equation number 33 and 34, where we have used this. Now, 533 and 534 is a functions of what? Vx and Vz, which we now want to get our Vx, for example, will be a function of Zh in time scale. So that will now make you to see that we will now plot our Vx in terms of what? Zh. You can also plot your V of Z in terms of that. So that is where we have reached. We can also begin to look at something else, because we said our problem will be based on the plasma beta. Plasma what? Beta. So we'll be able to look at that. But there are things that will come into the problem that will make it easier for us. If I want to look at that in terms of plasma beta, the problem will also change. All right? So the next step I'm going to give you is you will try it. Now, we are looking at beta. Our beta was defined as P naught over PM. That is the gas pressure. The gas pressure over magnetic pressure. And what did he give us? We ended up saying that this is equal to 2 over this of Cs squared over Vs squared, which is equal to 1.2 Cs squared over Vs squared. This is what our pressure is. But if you know the value of our Va squared, which you know, we can simply write this as 2 1.2 into C S squared. What is VA? VA is B rho squared over what? Mu naught rho naught. Is it not? So which will give me 1.2 mu naught CS squared over B naught squared of rho naught. Is it not? Now you go to where we define rho naught in terms of scale. Can you remember? Where we had it as something multiplied by e raised to power of zh. So you will have something that looks like this. Say a constant multiplied by e raised to power of zh bar. So this is, you'll find out what is A. So you should be able to find out what A is, because these are things that will help you. I've been able to compress 1.2 this CS squared B0 squared plus the one that will come here. I gave you what rho naught is. Did I not? Did I not? I did. If I open my book, who will give me his lunch? Today I must eat and get fat like the Birion women. You are laughing. Now you remember, we define rho naught to be equal to P naught at E minus Z over H. But if we have defined Z, you can now say Z over H will give you ZH, so that you'll now be able to see that this is the same thing as P naught E raised to the power of ZH. You see? Everything I write, I get way to get them. I don't just put things. So we have removed that. So if I now put that, you will see that our dish will simply give you 1.2 mu naught over b naught squared cs squared of another constant. Let me absorb that, E minus ZH bar. So that is what your B naught is. You will now see that with that, you'll be able to get the values of your plasma beta. So you can now see that the plasma beta decreases exponentially with respect to the height scale. Are you following me? So that is the physical interpretation. Now, in your numerical computation, you will need to find the values as applicable to solar corona or solar photosphere. There are the values I may try to give you in the photosphere, which you can also get them in the other one. Because their values are that, you vary them. In the solar atmosphere, particularly the corona, the magnetic field goes from 1 Gauss to about 10 Gauss. 1 to 10 Gauss. Maybe at the end of today, I should be able to write these constants and give you. Okay, maybe I can still go on before we go. And then I clean here. So, for you to practice using our Mathematica, you'll be able to see that we can plot the plasma beta. Plasma beta against your ZH. If you know some of these parameters. And then because of the presence of EDs, it will not tend to 0 easily. The value should go like this. You see that? Mm-hmm. Are you twins? Are you from the same father? You know, there was a time your director, they were doing a work on a pattern formulation. And then I had to be a peer reviewer for the work. A lot of things can be said about your fingerprint. A lot of things can be done with the signs on your palm. Come, let me show you something. No, only you. Okay, fine. Your father has how many wives? 2. Okay, wait. Do you have a younger one from your mother?
Yes.
From the same father?
Yes.
A girl?
Yes.
That is what I'm seeing for Israel.
He's shocked. His twin brother is shocked.
So you see, these are things we study in pattern formulation. And that is physics. So when I tell you physics is life. So you'll be able to know if your father and your mother are together and the wife comes, gets belly, gave birth, you'll be able to dictate whether that pikin Now you give them. You don't need DNA. You know, you see, there is what we call in a crystallography. It's a combination of game theory, group theory, and Boolean algebra. So these are mathematics. So we use it to do this. And then molecular physics. So because I worked with it for years, I don't need to consult anything to be able to read their palm. If I see you the way you wear a ring, the position of your ring, I can say something that is in your mind because of physics. Huh? You want to know? Yeah, sure. A lot of philosophers are mathematicians. Philosophers, psychologists, you should know a level of mathematics and physics. So when we now begin to say some of the things and the actions people live, you say, this man is a juju priest. It's not. It's scientifically proven. Okay. Now, we will try, I think on Thursday, tomorrow I won't be here. That's why I'm taking all the time. So that on Thursday we do our final dance. Now, in photosphere, parameters that are a little bit good. Photosphere. Okay, the parameters, most times, okay, let me start with photosphere. Photosphere, we have CS. The sound speed is about 10.5 kilometers per second. 10.5 kilometers per second. And the Alphian speed is about 0.077 times 10 raised to power of 5 meters per second. And the rho zero is 3 times 10 minus 4 kilogram per cubic meter, and P0 is giving us 2 times 10 raised to power of 4 Newton meter per day. These are some things you are going to see. You know, we have also said that mu0 is actually constant, and that gives us about mu0 gives us about 1.2566 times 10 minus 6 kilogram meter by this a minus 2. You see, when you do non-dimensionalization, you are removing all these factors. So you are at liberty to pick any value. Okay. Now, I talked about the speed. Okay. In the corona, you'll be able to compute some of these values from the relationship you have with this corona. In your corona, I'll just give you the speed. VA in the corona is about 890 kilometers per second. And CS here is about 151 kilometers per second. Then you can find P0. You find rho 0. This one, I will get the values for you. But you can pick the values from Bernard Roberts, 2000, I think 19 or 16, whatever, MHD waves in the solar atmosphere. I've given that book to you people. So it's a very good book. You have these values from there. In fact, yesterday, as we were doing something, I began to do some of the graphings. Yeah, direct. If you have a printer that has my own format, I can send it to PDF and you will print and see, so that you'll be able to practice this. Now, having given some of these values, we'll be able to plot the density, the pressure, the plasma beta as it corresponds to your particular layer, either photosphere or chromosphere. All right? So that as you practice this, you'll be able to know how these ones are. But our main task is for us to see how we can solve that problem. And I said the magnetic field in the corona gets from 1 Gauss to 10 Gauss. There is a recent mapping of magnetic field in this layer. If I maybe I'll also find out the journal article and send to you. It's in my system, but I can't remember the particular one. But you should take that. Now, and then also within the solar atmosphere, G acceleration due to gravity is about within 274 to some of them 277 meter per second. You see, here on Earth, we are talking about 9.8. Here, there is 274 to 277. So you have strong magnetic field. Okay. When you do all the things, I will write down some of the equations we are now going to see. We will, as I said, we will non-dimensionalize again after doing that, getting those equations. Here, we have done the first, we will still do another non-dimensionalization where our frequency will now be in terms of nu, and our wave number will be in terms of lambda. Those things are also wave number and a wavelength. So if we do that, we should be able to see exactly how the equations will now look like. When we get those equations, we can now solve them with some approximations. And I'm very happy because I'll not be here. My colleague will take you throughout tomorrow. So I'm taking your time, sir. Okay. Okay, we have two beautiful husband and wife. You know why they are husband and wife? They are coupled. You see, VX, VZ, VZ, VX. They are coupled. Now, the lambda is a representative of the wave number, and nu is a representative of the frequency. So, under this, nu is non-dimensional frequency, and your lambda is also non-dimensional wave number. The other constants are there embedded. Your beta, you can see beta there is the plasma beta. Your beta is the plasma beta. Which other constants? Of course, we know gamma to be heat index. We know your heat index. This is adiabatic index, which is 5/3. It's empty as 1.2. That is 5, yes, 1 point. Is it correct? What is 5/3? 1. Huh? Is it 1.6? Anyway, there are other things I will check. So whatever, just leave it. Okay, because if you multiply by 2 is when you have that number. Okay? Okay, fine. Now, we have taken all the parameters that are here. Now, these two equations, we said we are going to solve them for Vx and for Vz. Now, if we are to solve these problems, it could take us quite some time, because you are going to do elimination. And the way to do the elimination stands to tell us something. That is to say, that it might be a little bit difficult for us to do that. Now, because I must operate on one of the equations with d squared minus d plus this into the other one, it will give me a fourth order equation. Then I solve for one. Then I substitute the other one and get the other one. Now, you can see we have this equation, and which represents 533, 534. And we also have 531 and 532. These are the equations that are for us to be able to determine the next thing to happen with our velocity, because that's where we are. So I may decide to leave these last equations I've written here and concentrate on that 531, because we want to see when the field is weak and when the field is strong. When we say field is weak, it means that the magnetic field is what? Weak. Strong is for strong magnetic field. That's exactly what we're talking about. So I will clean this particular one and we'll do small analysis. Then I will tell you what to do subsequently and see whether you'll be able to achieve that. Because Thursday, by God's grace, all of us will be here. Okay? Your mathematical is working. Alright. So do they have their systems here? So you come with your systems. We'll do it and do it. Okay. Okay? Haven't you snapped enough? Digital, ba? So you collect the digital and send to me. Okay. Okay. We'll now try to look for. I told you there are ways to solve the problem. Either by elimination methods. So you should know how to use that. Or we can look for asymptotic solutions. Let's just look for asymptotic. Now, you will have your Google. Check what is the meaning of asymptote. Yes, check the meaning of asymptote. So that you should know where we are going to. Is there another thing? A line or a curve that is asymptote to given curve is called asymptote. And what does that mean? Something its value is approaching or a curve closely in a short time. All right? So we'll try to look at the asymptote. So that will give us solutions for weak and strong fields. For weak and then strong fields. So we want to look at situations where we talk about strong fields and then also the issue of weak fields. Now you can see one interesting thing that comes. The sound speed or acoustic speed does not depend on magnetic field. Is it not? True or false now? Oh, nah. See, CS squared is equal to what? Have you forgotten again? Is it gamma P0 over what? Over rho naught. What of your VA squared is equal to this Is it not? Over mu naught of rho naught. Now you can see that plasma beta, as we said, is equal to what? 1.2 CS squared over VA squared. We wrote these equations this morning. Is it not? Huh? Is it not? And then from them, you will see that beta VA depends on magnetic fields. So for us to look at the places or the layers of weak magnetic field and a strong magnetic field, it must depend on what? Beta. And during the course of our lectures, we'll say that the weak fields will occur when beta is far greater than what? 1. And then you will now see that the strong fields will be variable when beta is far less than 1. That's exactly what would demarcate the two sides of the solution. So we must have two nodes to consider for each field. Now, I will not do so much. Now, let us look for weak field and a fast mode. Now, the first solution we will consider, one, we will consider weak field and then fast node. After doing this, we'll be able to consider weak field and slow. Maybe we'll take weak field and then slow node. So these are two things. You see, from that same equation, there are so many things that will come under your analysis. So, coordinator, write down for me. Asymptotic solutions. Asymptotic solutions of MAG in solar atmosphere. After we'll tell you what it is. Asymptotic solutions of MAG waves in the solar atmosphere. You see, another paper has come up. So as we are going, things are coming up. All right, sir. So, this is one thing we said we would take. So, another thing we will look at is to look at strong field and strong fields. In this case, beta should be less than 1. And we also consider two solutions that will come. Slow and what? Fast. So we'll be able to look at strong field 1, strong field, and then fast node. Or we'll call it mode. Instead of that, you can look at that as mode. Let's look at it as mode. Because when we start going to that, number 2, strong field and then slow mode. Now, these are things that comes into analysis. It is no longer the solving of the equations. But now we need to get the physical meanings and physical situations of what we are doing. Now, still leave these two equations for me, because I'm going to work with those equations. Eh? Okay. Now, we will start with weak field. For weak field, what happens with weak field? The plasma beta must be what? What is plasma beta? Must be great. Eh? For weak field, you have that. And if you look at, for you to have a strong field, it means that your acoustic speed must be far greater than this. So, in fast fields or in weak fields, we'll start with weak fields. CS must be far greater than the reference speed. That is sure. Because if you look at, because beta, if this one is far greater than this will be far greater than 1. If this is higher than this will be less than 1, isn't it? So you see, that is one simple analysis. All right. So, let us look at those equations 5, 3, 1 and then 5, 3, 2. If we say that CA is very small, or the VA is smaller compared to CS, they are squares. That one will be very, very small. So in that equation, we will remove VA. Okay? Okay. Now, this will imply that in equation, what is our 5.31 and then 3.2 and 3.2, 5.3.2. Put VA will be approximately tending to 0. And what we are going to get will not surprise us. We will have minus CS squared KX squared minus what? Omega squared. All these ones are multiplied by what? V of x. Is it not? Is equal to what? That will give us kx into cs squared d by dz minus g into what? Vz. That's the first thing you will get. Is it not? And the second one, okay, that's the first one we will get. Because you see in the second equation, 532, there is no VA, is it not? So that one will remain. Let's work with this one first. No, I think that place should be plus, eh? Oh boy? That place should be plus. Please change that to plus in that equation. All of you. 5, 3, 5, 3, 1. In place of that minus omega squared, put it plus omega squared. Please. So that we don't get into problem. Now, we can now rearrange this equation to give us omega squared minus cs squared kx squared. Is it kx squared? Okay. Into vx will give us kx of cs squared d by dz minus g of vz. We can make x the subject of the formula. Okay? Because all these ones are constants. So we can make Vs the subject of the formula. And what would that give us? You will have that Vx will be equal to kx cs squared d of vz by dz all over omega squared minus cs squared ks squared minus g kx all over omega squared minus kx squared cs squared vz. So that is what we will have as our Vx. Now, you see as it is, we have obtained our Vx. But we will differentiate that equation and then use it in that 532. Are you following me? Eh? We will differentiate this equation with respect to dz. So you have dvx by dz. Here becomes d2vz by dz squared. Here becomes dv by dvz by dz, is it not? Which you will see their presence are in this equation. So you put the vx here and then simplify. Eh? Okay. So if you do that, you will have to differentiate